What if the strongest foundation for your home is not a massive slab of concrete, but a trench filled with loose stone? That sounds backward in a world obsessed with steel, cement, and bigger construction budgets. Yet some of the longest lasting structures in history were built on a surprisingly simple idea. For thousands of years, builders understood a truth that many modern construction methods ignore. The greatest threat to a foundation is not weight. It is water. That forgotten lesson may be one of the most valuable pieces of survival knowledge ever passed down through history. While modern homeowners spend thousands repairing cracked foundations, ancient builders relied on a system that naturally drained water away before it could cause damage. The technique is called a rubble trench foundation, and it has quietly supported buildings for centuries. The concept is astonishingly old. Long before concrete dominated construction, builders placed loose stone beneath load-bearing walls. The reason was simple. Stone does not hold water the way soil does. When tightly packed into a trench, it spreads weight efficiently while allowing moisture to move freely through it. Ancient communities used this method to support earthen and stone structures in regions where heavy rain could quickly destroy poorly built foundations. Instead of trapping water, the stone beds acted like giant drains. Water flowed through and away from the structure, keeping the ground beneath stable and dry. As civilizations advanced, the method evolved. Builders refined the process, creating stronger and more reliable foundations. The principle remained unchanged. Keep water moving. Prevent it from collecting beneath the building. Protect the structure from the ground up. That lesson became even more important in cold climates. Water expands by roughly 9% when it freezes. That may not sound like much, but the force generated by freezing water is enormous. When moisture becomes trapped beneath a foundation and temperatures drop, the expanding ice pushes upward against the structure. This process, known as frost heave, is responsible for countless cracked walls, uneven floors, and expensive repairs. Many modern foundations attempt to fight this force using thick concrete footings buried below the frost line. The problem is that concrete itself does not solve the water issue. Water still migrates through the surrounding soil and collects around the foundation. Special drainage systems are often added later to manage the problem. A rubble trench foundation takes a completely different approach. Instead of resisting water, it works with it. The system begins with a trench dug below the frost line. Rather than filling that trench with solid concrete, it is filled with compacted, washed stone. At the bottom sits a perforated drainage pipe that carries water away from the structure. The trench is lined with geotextile fabric, preventing soil from clogging the drainage path. Once the trench is filled, a narrow reinforced concrete beam is placed on top to support the walls. The result is a foundation that carries structural loads while functioning as a permanent drainage system. This dual purpose is what makes the design so powerful. Water never remains trapped beneath the building because it continuously drains away. Without trapped water, frost heave has little opportunity to occur. The foundation stays stable through freezing winters and wet seasons alike. The effectiveness of this system is not just theory. Modern testing has repeatedly demonstrated its performance. Research conducted on frost-protected foundation systems showed that properly designed stone-based foundations remained stable even during severe winters. Ground temperatures stayed above freezing, and no significant frost heave occurred. Meanwhile, entire regions have quietly relied on similar principles for decades. Across Northern Europe, millions of homes sit on foundations built around drainage-first concepts. In some areas near the Arctic Circle, these systems have become standard practice because they consistently outperform traditional approaches in harsh climates. For survival-minded builders, the advantages extend beyond durability. Cost is a major factor. Conventional concrete foundations can consume large amounts of material and labor. A rubble trench foundation dramatically reduces the amount of concrete required. In many cases, concrete use drops by as much as 80%. That reduction translates directly into savings. Depending on the size of the project and local material costs, builders can often spend far less than they would on a conventional footing system. For homesteaders, off-grid builders, and preparedness enthusiasts, every dollar saved can be invested elsewhere. The environmental benefits are equally significant. Cement production contributes a substantial share of global carbon emissions. Reducing concrete use lowers the environmental footprint of a project while preserving the structural performance needed for long-term reliability. Of course, no foundation system is perfect for every location. Soil conditions matter. Rubble trench foundations perform best in stable, well-draining soils with adequate load-bearing capacity. Highly expansive clay soils can create challenges because they swell and shrink with changing moisture levels. That is why soil testing remains one of the most important steps before any construction project begins. A simple geotechnical evaluation can reveal whether the site is suitable and help prevent costly mistakes later. The actual construction process is surprisingly straightforward. After excavation, the trench is graded to ensure proper drainage. Geotextile fabric is installed. A perforated drain pipe is laid at the bottom. Clean crushed stone is added and compacted in layers until the trench reaches grade level. The fabric is folded over the stone, and a reinforced grade beam is poured on top. From that point forward, construction continues much like any other building project. The difference is hidden beneath the surface, quietly protecting the structure year after year. Perhaps the most fascinating part of the Rubble trench story is not the engineering. It is the lesson behind it. History is full of solutions that worked so well they survived for centuries, only to be forgotten when newer methods became more convenient or profitable. The Rubble trench foundation is one of those solutions. It proves that durability does not always require complexity. Sometimes the smartest designs are the simplest ones. A trench. Loose stone. Gravity. Water moving where it wants to go. For preppers and homesteaders, that lesson carries real weight. Resilience often comes from understanding natural forces rather than fighting them. The builders of the past understood that. They designed foundations that drained themselves, adapted to changing conditions, and endured for generations.